Okay, everyone. So before we get started, I just want to remind everyone that all of you guys do not have mic privileges. The only person that has mic privileges is going to be Matthew and myself. If you guys have a question, please post it into the chat box, and Matthew will get to it after his presentation. We do not, if the speaker wants to answer your question during his presentation, that's entirely his prerogative. But again, we reserve the right to tell you guys to ask him afterwards. So with that, Matthew, go ahead.
All right, well, thanks a lot. My name is Matt Wright. I'm the director of the Center for Cybersecurity at RIT. I'm going to talk about a vision for human-centered cybersecurity. So before I get to what exactly that means, I just want to talk a little bit about the center so you know a little bit more about me and what we're talking about today. So the Center for Cybersecurity is a relatively new research center at RIT. We do three main things. So the research, of course, outreach, and education. And in the research side, related to some of the stuff I'm going to talk about today, we want to make sure that we're touching on interdisciplinary research, and in particular, this topic of human-centered cybersecurity. In the other thing that I'll mention is in the education and outreach components, we try to tie into the research so that the students are getting real-world experiences, research experiences in terms of their projects, their courses, and so that that's enriching their education. Okay, so what is this thing about human-centered cybersecurity? A lot of people, when they think about cybersecurity, are thinking about technical things. You think about, cryptography, smart cards, biometrics, advanced machine learning algorithms. And those things are all part of course, what cybersecurity is about. But when we look at actual cybersecurity incidents and what is it that causes them, or what are different aspects of cybersecurity in the real world, we see that humans are really at the center of everything. They're really at the center of every different aspect of cybersecurity, from the users to system administrators, software developers, and even the attackers are people, and which means that they come with all of the flaws and problems that people have, as well as whatever expertise they might be bringing to that attack. So the most obvious example of where humans interface with cybersecurity is in user interfaces, and I'll talk a little bit about that first to give a flavor of some of the things that we think about when we think about human-centered cybersecurity. This is a quote-unquote security blanket. It's actually a quilt, which you have to look carefully at the slide details to kind of see, but this is quilted by Lori Craner, who's a passwords researcher at Carnegie Mellon. And this is, of course, a word cloud, which is probably what you first noticed. It's a word cloud of popular passwords. And the idea that there are such a thing as popular passwords tells you something about the problem with passwords as an authentication system, as a security system. That you've got passwords like 1, 2, 3, 4, 5, 6. And if you say, oh, that's very common, well, that means there's lots of people using this exact same password, which makes it much easier to crack into systems that allow that. And we would argue that the burden on the users is really the problem here. You have users who are not security experts, for sure. They're not memorability experts either. And you're asking them, all right, to create a unique string that is hard to guess, hard for an attacker to guess, given all the different things that attackers know, And you know, they know all the password tricks that you and I use, changed S's to dollar signs and all that type of stuff, and make something that is actually memorable, that you will remember, and ideally not have to write down, although that's another aspect of the human-centered cybersecurity issue. And then do that for every single site that you log into, every single, your work password, every single website that you log into, every service that you use, you need a password for. Clearly, this is not going to scale, and it doesn't scale, and it doesn't work, which is why we have so many problems with passwords as user authentication technology. So one of the things that we've been looking into is whether system-assigned passwords could be an alternative. System-assigned passwords have a lot of really nice features. So the most obvious one is that you can provide a guaranteed known security level. You can make a password that's a certain length, and each character is randomly selected. And now you know how much security there is. And if there's a system administrator out there, they go, okay, not only do I know that most of the passwords in my system are good, like 90% of the passwords are good, well, that still leaves 10% of the passwords that are bad. Right? With system-assigned passwords, 100% of the passwords are as good as you require them to be. Right? And in fact, it's tunable. You can say, well, I want this level of security, or I want that level of security, and you can trade that off against, well, how long is the password to type, how difficult is it to use. And one of the things that's nice, if you have it for your phone, right, you can be typing it in, and you don't have to switch from uppercase to lowercase letters to special characters and numbers. Oh, not those special characters, the other special characters. You can get rid of all of that and say, I just make the password long enough so that I can make it all lowercase letters. It's easy to type on any device. So those are nice. The problem is, well, these are some random strings. You know, are you going to be able to memorize these? Okay, so good luck. This will be a quiz later in the presentation. The threat models that we're interested in, whenever we do security, we want to be thinking about, well, what's the attacker capable of here? And so there's two things that we can think about. The first and the primary attack model that we consider in our work is called the popular password attack. We're thinking about, okay, the attacker is using the same website or interface to try to get into the system as everybody else. So, you know, maybe they can use some scripting or something, but they're going to be basically just having a computer type passwords in, send them over the network, the same as a regular user. In this case, you run into things like, well, you can only use so many passwords before the system will lock out your account. And users can have, and so the attacker can maybe try a few of the most popular passwords on a range of the accounts that are available. And so you might be thinking, okay, well, what if they have to have uppercase letters and special characters? Well, the attacker knows what, given the rules, right? They have actual data sets of passwords. And so they can look at it and say, given the actual rules that are required by this site, I can craft the most popular passwords, and I can try them on account number 1. And I try enough, but not too many to lock out the account. And then I try it on account number 2 and account number 3, and so on down the line until I get in, right? And if the system has some users using some of these popular passwords, then that's going to be successful for the attacker. Another attacker that we might consider is what's called a dictionary attack, or brute force attack in the world of passwords, where the attacker is able to try many, many different passwords because they've managed to get a hold of the password, what we would say the encrypted password or the hashed password, get a copy of that, and then try many variants of passwords until they get one. In which case, if that's the attacker model, then you have to have a much more secure password system. All right, so I bet you thought I was kidding when I said there would be a quiz, you remember the passwords? Okay, most probably not. Maybe there's one person in the audience who is, yes, I actually remember the passwords, but it's very unlikely. And of course, so system assigned passwords, the main problem is that they're hard to remember. So what do we do? Well, that gives us the challenge, right? The challenge is we know that there's so many good things about system assigned passwords. We think that they're very helpful. And in terms of taking the burden off of users, they're great because the security part is taken care of, right? We're not asking the users to come up with something secure anymore. The problem is that people need help to remember them, okay? And here we think the system can also step in and provide some help to the users. And I'm going to talk mainly about queues, because I'm going to keep this relatively short before moving on to some other topics. So the system that we designed is called QueuedR, and this is actually a kind of an early version of the system. And I don't mean this to be like the full replacement, certainly not for all password systems that are out there, but it could be an approach that would be of interest in some cases. Say, for example, a single sign-on in a situation like at work, or for specific cases where everybody's password needs to be at least at a certain level. So here we've got a picture or a profile, a portfolio of a set of animals. And in this case, you're assigned zebra by the system randomly from all of the different animals on here. You don't get to choose. So we're removing that aspect of users' choice, because, you know, if you let users choose, they're just going to choose the cutest kitten in the whole bunch, and then that's going to be the end of it. So we don't let the user choose, but we're going to help them remember the zebra by giving them some additional cues, some information that we provide both when they register their password, as well as and learn the password, as well as later on when they log in. So here we see a zebra. We've got a picture of a zebra, right? That's a graphical cue. We also have what's called a spatial cue. The zebra is always next to the cheetah and the elephant. I've got some stuff on my screen, I can't exactly say. A cheetah and elephant above the koala. And so you kind of, and towards the upper left-hand corner. So you know approximately where to look if you're looking for this when you're logging in. You don't remember right away that it's zebra, but you can look in the right place. And then there is the verbal cue. So we have every zebra has a unique pattern of stripes, right? And so that is a verbal piece of information that goes along with zebra that helps you remember, oh yeah, I've been assigned zebra. Here I'm being shown every zebra's unique pattern of stripes. A little additional processing for your brain to go over when considering trying to remember this password. And we find that this technique works very well. Over the course of 1 week, users, 100% of the users in our study, our first study on this, were able to remember their password. And it's 6 lowercase, the equivalent of 6 lowercase randomly assigned letters. Normally you give users 6 lowercase randomly assigned letters, and the memorability rate is something like 60%. So it's significantly better than that kind of control. Okay, so that's one aspect of user authentication, which is one aspect of human-centered cybersecurity. Another aspect, work by my colleague Josephine Wolf, is on the impact of two-factor authentication. Two-factor, I think you're probably all familiar with. You have to log in, and then you also have, for example, an app or an SMS message that comes on your smartphone that lets you know a code that you can then enter into the website. It basically tells the website, yes, you really do have that device. And so when you're logging in, you're not just showing that you know a piece of information, which is the password, but also that you have a token, or in this case, your smartphone. So she works with the Duo two-factor authentication company. And yeah, so there you see a graphic from Duo that shows the password plus the proof, which is this app authenticator, provides you with the access. And this is very important in security to prevent phishing, password breaches. If somebody gets a hold of that password database and they're able to crack some of those passwords, they're not able to use them unless they also have access to your smartphone. Right? So that's a much stronger defense. So with Duo, Josephine has been asking questions like, well, what is the impact of two-factor authentication on account compromise? And I think what's interesting about the work that she does is that she not only has data from the Duo company, she works with a university that also provides information about account compromise. So two separate sources of data, and then she can correlate, well, these users are using SMS messages, and these users are using a key fob, and these users are using the smartphone app. And so which users are the most secure against attackers trying to compromise accounts? And so some of that also includes working with users, surveying users to understand barriers to usability and adoption. So if you take your smartphone out of the country and you don't receive SMS messages in the other country, now you can't log into that account, right? Things like that that need to be considered when designing and developing two-factor authentication systems. So when we think about human-centered cybersecurity, certainly users are a big piece of that. We've just been talking quite a bit about that side of things. Another aspect that's very important is tools for professionals. So security professionals and software developers are really on the front lines a lot of times in terms of understanding security incidents, dealing with them, or developing the software that if it has bugs, it's going to lead to serious security issues. And I'll start by talking about that piece of it. This is some work by my colleague Andy Maneely, who is in our software engineering department. And he works on mining of software repositories. So there's these software repositories, such as the well-known one called GitHub, where developers are putting their software projects and their code. And so you can go there and you can look at the code that they've developed, and you can check it out to build a new project of your own. You can, on some projects, you can try to contribute your own code to the project. And some of them are, and so there's lots of different types of projects and so on. And what Andy is working on is, okay, can we try to understand what types of security bugs are out there, and do that by using data mining techniques on these software repositories like GitHub. So what happens here is that, say we've got a white hat hacker. So we've got a good guy, someone who's trying to understand and research security vulnerabilities, and is looking at a particular software product and says, oh, I found a security bug. Okay, so typically that hacker is going to report that both to the company and in responsible disclosure, but as well as to report that to databases that describe the different vulnerabilities in software systems. So CWE and CVE and Bug Tracker, common ones that are out there. So report that to these databases, and where Andy takes over is he can look at the database and see that, okay, there's this vulnerability here. And now I can go, and I know that this is an open source software project where the source code is available in GitHub. So I can look at that source code. And so here we see some source code, not real source code. This is sample code I use in my class, but it goes, okay, here's a bug. I found this bug here. And this is the day that he's looking at that software. That was when it was checked in. But you can, one of the nice things about it is, about these software repositories, is that you can look in the past. And so you can look to see, oh, this is what happened yesterday. Somebody checked in a version of this code and it looks a little bit different, but it still contains that bug. So we'll keep going backwards in time. And eventually it goes, oh, okay, this is when the change in code, that bug, was actually introduced. And now we can start asking some interesting research questions like, well, which developer was it? Which, did the developer do other software check-ins that we can look for this type of bug? Do they make this bug consistently? How experienced is the developer? Is the developer in a team? One of the interesting findings is that if you have a team of developers that is, well, if you have a single developer, right, they're more likely to make a mistake and have it not get caught than if you've got a couple of developers or 3 developers. But once you get up to about 6 or 7 developers who are working and responsible for a particular line of code, the chances for a security bug not being caught go back up. And the reason for that is you've got so many different people who are responsible for the software that they all think, oh, okay, well, he's got it. No, he's got it. No, she's got it. Well, nobody has it, right? So some of these things that can be explored in the software. And then if you understand, well, what are the security bugs that are being developed and why are they happening, then you can start developing tools and best practices and processes for developing software that are going to lead to fewer security bugs. So another aspect is for security and IT teams. Those who are, when there is a security breach, the ones who are actually looking at the alerts that are coming in and saying, oh, I see that there is a security problem here. And this is a slide from Palo Alto Networks, but a lot of companies are realizing this is a problem. There are lots and lots of tools that are out there that are intended to help. They are intended to provide useful information to these security analysts. But the problem is, as you can see in this picture, these teams are being overwhelmed by huge amounts of information, too much information. Here's another pictorial that just shows, I mean, it's pretty much impossible to read because there's so many security tools that are out there. Right, so too many security tools, you know. Well, what's gonna happen is, of course, a lot of these tools are not gonna get used. Right, they're gonna get ignored. They're not part of the flow of what the person is actually doing. So this is where my colleague Esa Rentinen, who is a professor in psychology, comes in. And so when we talk about human-centered, it doesn't get more human-centered than a psychology professor, right? So he uses this technique called cognitive work analysis, which is something that has been used a lot to do situational awareness. For example, for aircraft control, you've got, you know, that screen with the dots moving around, and you have to look at that and you have to understand which of the pilots you've talked to, what else is going on, and, you know, are these two planes going to crash into each other? And there's a lot of information and you have to be able to process all of that. Well, the cognitive work analysis is a tool, is a psychology tool. So basically it's a process. It's a bunch of questions is what it comes down to, a bunch of interviews and a way of structuring all of that to understand how people do a job. What's the context? You have a task, but what is the context of that task? Where does that fit in? What tools fit in around that? What tools facilitate that task? And where we think that that can be useful is to study security analysts, to say, well, there's all these tools that we just looked at, right? All of those tools. Well, that's so many tools. Which of these are actually useful or should be useful, right? Which aspects of the security analyst job require this type of tool or that type of tool? And then given their current workflow and the way that they process information, what would be more useful? Or of the tools, which would be most useful? And then can we design a tool that would be even better, that would do a better job of accounting for what security analysts are doing in their work? All right, so the last piece that I'll talk about before I turn it over to questions is modeling. So we have a researcher here who's also the chair of the computer engineering department, Jay Yang. Jay works on modeling and simulation for attackers who's trying to do advanced cyber attack simulations. And so in order to do those, you have to understand a lot of different pieces. You have to understand what is the user acting like? What is the network like? What are the systems going to do? How are they going to behave? What about the security systems and the security analysts? And all of those things, some of that is, requires understanding what people are doing. Some of that does not. Some of it just requires understanding what the system is up to. One of the things that's really tricky in all of this is you also need to understand the attacker. So Jay has been working with psychologists and criminologists in order to get a better picture of what are the processes that the hackers are going through in order to do a good model of a cyber attack in a real network, right? To make things as realistic as possible. And if we can do that, then you can come up with a better understanding of what attackers are up to and how it makes sense in the flow of the system, as well as to design better defenses, or just to place defenses in better places, or to tune defenses to make the most use of information. And eventually to get to, and one of the things that Jay is really interested in is, can we predict what attackers are going to do, right? And so with good modeling and good simulation, then you can do that, but it requires that human-centered part, in this case focusing on what attackers do and the types of processes that they follow, because they're not random number generators. They are people who have a certain set of patterns and behaviors. And if we can understand that, then we can do a better job. So to wrap up, we've been talking about this notion of human-centered cybersecurity, and I put this all under an umbrella, or I'd say human-centered cybersecurity is an umbrella that encompasses a number of these different areas. So one is the user interfaces, like user authentication. We also study phishing in particular. We've been looking into phishing in social networks as another significant problem. Two-factor authentication is another aspect in user interfaces. And then there's another piece of tools for professionals, right? So we have software developers, and can we develop better tools for them, as well as security administrators? What kind of, can we develop visualizations or other tools that would be helpful in the context of the work that they're actually doing? And then modeling and simulation, trying to understand what is the attacker up to so that we can do a better job of predicting their behavior and developing defenses based on that. So that puts the people, the animation order was wrong, but that puts the people back into the center of the cybersecurity picture. And so with that, I am happy to take any questions that you would have. All right, so Edward asks, what role do you see AI playing within the cybersecurity landscape? I think AI is going to be very important. It already is important. Certainly a lot of tools and technologies are already starting to incorporate AI in order to understand, for example, attack detection, malware classification. These things are starting to use AI in a big way. But certainly, as a researcher, and when I look at the research landscape, I see AI penetrating everything that we do. And in particular, that's also stretching into deep learning. So when you hear about deep learning, and that is also getting into aspects of cybersecurity, deep learning and intrusion detection. There's a system paper that was out, I think last year, called Deep Log, right? Looking at that. Definitely in malware analysis. And I think that another thing that's interesting, that I've become very interested in, is that you can actually try to attack machine learning itself. So you can have, for example, you have these computer vision algorithms that can look at different objects and say, oh, that's Matt Wright's face. Oh, that's a whiteboard, right? They're very good. They've gotten, using the latest state-of-the-art systems, they can detect between thousands of different types of objects with very good accuracy. And one of the things that, so a really good example of attacking one of these systems that has a real practical impact is there are these papers out now that have been saying, okay, sometimes you could imagine using this in a driverless car, right? A self-driving car is going to be looking around and trying to identify different objects. And what they were able to, these researchers were able to do is take a stop sign, manipulate the stop sign by putting stickers on it, such that as the car is driving up to it and taking pictures of the stop sign and trying to identify what it is, it actually reads as speed limit 45 miles an hour. So you can see that, okay, well, that's a problem for a self-driving car. And then it becomes a really interesting question. What can we do about that? Can we make these AI systems, in order to be used in security-sensitive applications, which is most applications, then they're going to have to be robust to that type of attack. So that's also a really interesting up-and-coming thing. Are there any other questions? Oh, there we go. In the past, the FBI created models for predicting serial killers. Do you know if any modeling is being generated currently by any law enforcement agency for cyber attackers? That's a great question. So what I can tell you about is the work that Jay is working on has been funded by the government. So one of the agencies is, so some of it was funded by the National Security Agency, some of it was funded by IARPA, which is, if you know DARPA, the Defense Advanced Research Projects Agency, this IARPA is the intelligence version of that. So they have funded Jay's work on that as well. So it's certainly a topic of interest. Beyond that, I don't have any other inside information. I'm not sure if I had other inside information, maybe I would be able to tell you. Sure, happy to help. Anybody else? I'm surprised there's no password questions. Usually that always gets a lot of interest because everyone uses passwords. But maybe not.
Okay, well, thank you so much, Greg, for participating today. I do have a couple of announcements. You can find Greg's, it's going to be a PDF version as well as his talk from today on the CAE and Cybersecurity Community website. And again, I posted that link in the chat box if you guys are interested. So thank you guys for coming out. If you guys are interested in participating, I also included the link to, or the email address to contact us there. So thank you guys.
All right, thanks all.